Did you know that 70% of the world's cocoa beans come from West Africa, where farmers earn just 6% of the chocolate industry's profits? The chocolate bar you enjoy goes through over 10 different industrial processes before reaching your hands. In this documentary, we're taking you inside the real chocolate factories, where temperatures must be controlled within just a 10-degree range for quality chocolate. From machetes harvesting cocoa pods to 25-ton hydraulic presses extracting cocoa butter, you're about to see the chocolate manufacturing process most consumers never witness. The chocolate bar in your hand began its life thousands of miles away in a completely different form. What exactly happens before cocoa ever reaches a factory? The journey starts in tropical regions where cocoa pods flourish under specific climate conditions found only in a narrow band around the equator. West Africa dominates this production landscape, with Ghana and Ivory Coast alone accounting for 70% of the world's cocoa supply. Behind this massive industry stands an army of farmers who, despite their crucial role, receive a mere 6% of the chocolate industry's profits while performing the most physically demanding aspects of production. Harvesting these precious pods requires exceptional skill and precision. The process has remained largely unchanged since ancient Mayan times, with harvesters using specialized tools like machetes, picaroons, and shears. Unlike most fruits that grow from branches, cocoa pods emerge directly from the tree's bark, requiring careful cutting to avoid damaging the trunk. A single mistake could prevent the tree from producing future pods, making the harvester's expertise invaluable to maintaining sustainable yields. After collection, the real transformation begins. Workers methodically crack open each pod by hand, revealing a surprising sight: 20 to 40 beans nestled within a sweet, white pulp that bears absolutely no resemblance to chocolate. This stark difference between raw material and final product underscores the remarkable transformation that follows. The beans and their surrounding pulp are then gathered for the next critical stage in their metamorphosis. Fermentation represents perhaps the most crucial biological process in chocolate development. Freshly harvested beans, still coated in their white pulp, are placed carefully into wooden boxes and covered with banana leaves to create the perfect environment for microbial activity. What happens next is nothing short of alchemy. A two-stage fermentation process begins. First, ethanol fermentation takes place, followed by acetic acid fermentation, with oxygen levels playing a decisive role in aromatic development. For 3 to 9 days, this complex biochemical dance continues. Bacteria present in the environment work their magic, breaking down the white pulp and triggering chemical reactions that kill harmful microorganisms while developing the essential flavor compounds that will eventually create chocolate's signature taste. As you observe this process, you'd notice the beans gradually changing color, transforming from pale to a rich, characteristic brown. Visual evidence of the hundreds of flavor compounds being created inside. The fermentation must be stopped at precisely the right moment, transitioning the beans to the equally important drying phase. Farmers spread the beans across wooden decks, where they're exposed to sunlight and fresh air. This traditional method serves dual purposes, removing excess moisture while continuing to develop the beans' flavor profile. The timing here is critical. The beans must reach exactly 7% moisture content over a period of 5 to 7 days. Too wet and dangerous mold will form. Too dry and essential flavor compounds evaporate, leaving the chocolate flat and one-dimensional. Throughout these labor-intensive stages, skilled farmers make countless decisions that directly impact the final product's quality. They monitor fermentation temperatures, assess bean development, and determine the perfect moment to transition between stages. The extraordinary attention to detail continues through the drying process, where beans must be regularly turned and protected from rain while maintaining proper airflow. Once dried to perfection, the beans are carefully sorted and packed into 1-ton sacks, ready for their journey to chocolate factories around the world. At this stage, the beans have undergone radical transformation through multiple biological processes, yet they're still just raw material. The color, aroma, and fundamental flavor compounds are established, but they bear little resemblance to the chocolate that will eventually emerge. Those 1-ton sacks arriving at chocolate factories hide a critical secret: they contain virtually no recognizable chocolate flavor. Before a single bean enters production, a specialized team performs what might be the most important step in the entire process: quality inspection. These highly trained sensory analysts meticulously examine incoming shipments, checking for moisture levels, mold contamination, and conducting detailed flavor assessments. They'll even cut beans open to examine their interior color and consistency, rejecting entire batches for microscopic defects that most consumers would never notice. This rigorous quality control isn't mere perfectionism, it's a manufacturing necessity. Even minor imperfections in the raw materials can compromise entire production runs worth millions of dollars. The inspectors serve as gatekeepers, ensuring only beans with the proper characteristics move forward into the transformation process that will eventually yield chocolate. Once approved, the beans enter massive gas-heated spherical roasters where the true alchemy begins. Inside these giant rotating drums, temperature control becomes absolutely crucial. The beans tumble at precisely maintained temperatures between 90 to 100 degrees Fahrenheit, a narrow window where something remarkable happens. The Maillard reaction. This complex chemical interaction between amino acids and reducing sugars triggers a cascade of transformations, creating hundreds of new flavor compounds that simply didn't exist in the raw bean. The roasting process simultaneously reduces the bean's moisture content from approximately 7% down to just 1%, enhancing their aroma while making the next step possible. The beans emerge from the roasters transformed, their flavor profile now fundamentally altered, but they're still encased in protective shells that must be removed. The beans then move to the winnowing machines, where they're cracked open and separated from their husks. These specialized devices use a clever combination of mechanical crushing and carefully calibrated air currents to efficiently separate the valuable nibs from the lighter, inedible shells. Inside the winnower, vibrating shelves shake the cracked beans while fans blow away the papery husks, leaving behind only the essential components needed for chocolate production. What remains are the exposed nibs, small fragments composed of approximately 50% cocoa butter and 50% cocoa solids. Despite undergoing multiple transformations, these nibs remain hard, bitter pieces that still bear little resemblance to commercial chocolate. Their flavor profile has been established, but their physical state is entirely different from what consumers recognize as chocolate. The next stage of transformation begins as these nibs enter industrial grinders. Here, intense pressure and friction generate significant heat, causing a remarkable physical change. The cocoa butter within the nibs begins to melt. As grinding continues, the once solid fragments transform into a flowing, deep dark brown substance known in the industry as chocolate liquor. This name creates some confusion for visitors on factory tours, as chocolate liquor contains absolutely no alcohol. It's simply the pure, liquid form of ground cocoa nibs, with all original components still present in their natural proportions. The grinding process fundamentally changes the substance's physical state, converting it from solid fragments into what resembles an extremely thick syrup. At this stage, the transformation has been dramatic but incomplete. While containing all the essential elements of chocolate, this chocolate liquor lacks the refined texture and balanced flavor profile consumers expect. It's a pure, unmodified form that serves as the foundation for all chocolate products, containing the full intensity of cocoa's natural characteristics without any adjustments for sweetness, dairy components, or texture refinement. This unrefined chocolate liquor contains all the essential components of chocolate, but in a form that would shock most consumers. What transforms this harsh, bitter substance into the silky smooth chocolate that melts perfectly on your tongue? The answer lies in precise engineering that breaks down and rebuilds chocolate at the molecular level. The transformation begins with massive hydraulic presses that exert up to 25 tons of pressure on the chocolate liquor. These industrial giants perform a critical separation process, squeezing out cocoa butter from the solids. This separation gives manufacturers unprecedented control over the final product's composition. By isolating these components, chocolate makers can recombine them in exact ratios appropriate for different chocolate varieties. This precision is essential because the formulation requirements vary dramatically across chocolate types. Milk chocolate typically contains only 10 to 20% cocoa solids, while dark chocolate varieties range from 50% in semi-sweet products to as high as 90% in ultra-dark varieties. White chocolate contains no cocoa solids at all, only cocoa butter combined with sugar and milk solids. Each formulation presents unique manufacturing challenges that require different processing techniques. For milk chocolate production, the manufacturing process continues as precise quantities of additional ingredients are introduced. Computer-controlled mixing tanks combine sugar, milk powder, extra cocoa butter, and emulsifiers like lecithin with the chocolate liquor. These emulsifiers serve a crucial function by helping prevent fat and water molecules from separating, contributing to chocolate's smooth mouthfeel. Despite this careful mixing, the resulting chocolate mixture remains surprisingly gritty. The particles in this stage measure up to 100 microns, 5 times larger than what human taste buds can detect as smooth. Our tongues can identify any particles larger than approximately 20 microns, which is why unrefined chocolate feels coarse and sandy rather than silky. To address this textural problem, the mixture enters refiners equipped with 5 precisely calibrated steel rollers. These rollers rotate at different speeds in a carefully orchestrated sequence, progressively crushing the solid particles. Each roller gap becomes incrementally smaller, reducing particle size from 100 microns down to the critical 20-micron threshold. What emerges isn't smooth liquid chocolate, but rather a dry, flaky substance that still lacks the characteristic melt-in-your-mouth quality consumers expect. The final transformation occurs during the conching process, named after the shell-shaped vessels originally used. Modern conching machines feature powerful mixers that stir the chocolate continuously for 24 to 72 hours while maintaining precise temperature control. This extended mixing serves multiple purposes. It distributes cocoa butter evenly around each solid particle, allows volatile acids to evaporate, and develops hundreds of nuanced flavor compounds through controlled oxidation. During conching, both physical and chemical changes reshape the chocolate's structure. The intense mechanical action coats each microscopic particle with a thin layer of fat, creating a lubricating effect that yields the smooth texture characteristic of fine chocolate. Simultaneously, moisture content drops below 1%, eliminating any trace of grittiness. The process also removes harsh, acidic notes through evaporation while developing the complex flavor profile chocolate lovers crave. Different chocolate types require specific conching parameters. Milk chocolate typically needs 16 to 24 hours, while dark chocolate benefits from extended conching periods of up to 72 hours to develop deeper flavor complexity. Temperature control remains critical throughout this phase. Too hot, and valuable flavor compounds evaporate. Too cool, and the proper texture won't develop. The engineering precision behind chocolate manufacturing represents one of food science's most impressive achievements. Through exact control of particle size, ingredient ratios, and chemical processes, manufacturers transform a harsh, gritty substance, extracted from tropical seeds, into the smooth, complex flavored material that defines quality chocolate. The journey we've traced from equatorial farms to gleaming factory floors reveals an industry now at a crossroads. Chocolate manufacturers are increasingly embracing direct sourcing initiatives that bypass intermediaries, enabling them to pay farmers directly for their crucial role. Certifications like Fair Trade guarantee minimum prices plus premiums that fund social and environmental projects in cocoa-growing communities. This shift isn't merely altruistic, it's responding to evolving consumer preferences. Studies confirm shoppers increasingly select brands demonstrating fair labor practices, environmental stewardship, and supply chain transparency. These informed consumers recognize that behind each satisfying snap of chocolate lies a complex global network of expertise, tradition, and innovation, spanning multiple continents and countless skilled hands.